Now, in the last lesson, we have looked at what are salts and the different methods that we can use to prepare them, and we have in particular answered two questions: what method to use for a particular salt, and what reagents do we need to mix in order to get the salt. Now, in this lesson, we're going to look at how to carry out each method, the procedure or the steps involved for each method. Right, we'll start with the precipitation method. Right, this is an example of a question that you will get. Describe the method for preparing pure dry barium sulfate salt. Right, from what we have learned in the last lesson, barium sulfate is insoluble, so we need to use the precipitation method. And some suitable starting reagents to prepare barium sulfate would be sodium sulfate and barium nitrate. Now, essentially, the precipitation method is the easiest of the three methods. All you need to do is to mix the two solutions in a beaker. Alright, so let's say I have sodium sulfate. Inside the beaker, I'm going to pour barium nitrate into the beaker. And once I've poured it in, I will use a glass rod to stir. And what will happen is that I will see some precipitate forming. So after no further reaction is observed, now we need to collect the precipitate, which is essentially your barium sulfate. So right now we have a mixture of an insoluble solid in a solution. So the ideal method for separating them, for collecting the insoluble solid, would be to perform a titration, a filtration. Alright, so we'll pour the mixture into a setup for filtration, and then we'll collect the residue here, and we'll have the filtrate. Now, for the precipitation method, we want to collect the insoluble salt, which is your barium sulfate. So it's essentially your residue that you want to collect. So now that we have barium sulfate in the residue, the method doesn't stop here, because right now the residue may be contaminated with some of the remnants of the solution. So what we need to do is we need to wash with some cold distilled water. Alright, why do we need cold water? Why do we need only a bit of it? Is because even though the residue is insoluble in water, all salts have some solubility in water. So we want to avoid having too much of the salt dissolving in water. So one way will be to use as little water as possible. The other way is to use cold water, because we have learned that hot water or solubility actually increases with temperature. So when you use hot water, you can dissolve more of a salt than when you use cold water. Alright, so in this case, when we are washing the salt, we need to use a little, and we need to use cold water or distilled water. Alright, once we have washed, the residue is now pure, it's free of contaminants. We need to dry it. There are many ways in which you can dry the solid. Alright, one way is to let it dry in the presence of air, alright, to let the water evaporate. The other way is to use the filter paper, use another piece of filter paper to gently tap it. Alright, and then another common method is to put it under an infrared lamp. An infrared lamp simply provides the heat for the water to evaporate more quickly. Now, for some salts we can actually dry it by putting it in an oven, but that method is not recommended, because there's a chance that the precipitate may decompose under the high temperatures. Alright, so drying in an oven would be not encouraged. Now, the procedure that I've just described here is summarized in this series of steps. Alright, there are certain steps that carry more meaning than others. For example, stir until no more precipitate forms. So why is this step necessary? Is to ensure that the reaction goes to completion. Alright, or rather, the reactants are completely reacted. Alright, and then washing the precipitate with some cold distilled water. Why must it be cold? Once again, we want to prevent the residue from dissolving. Into water. Alright, now we'll move on to the second method, which is called the excess method. Alright, again, this is another example of a question that you will get. Describe the method for preparing pure dry zinc sulfate crystals. In the previous lesson, we have learned that zinc sulfate is soluble in water. It's not a sparse salt, so we need to use the excess method. And a suitable starting reagents would involve an acid and an insoluble solid. So in this case, for zinc sulfate, the acid that we'll use is sulfuric acid. And then the other reagent, the insoluble solid, would there are three possible options. You can either use zinc, you can use zinc oxide, or zinc carbonate. In this case, I would use zinc carbonate. Alright, so first I will put sulfuric acid in a beaker, and then I will add an excess of zinc carbonate. Alright, on adding zinc carbonate into sulfuric acid, there's actually an observation that you can make. Alright, and the observation is that there will be bubbles. Why are there bubbles? Because when an acid reacts with a carbonate, carbon dioxide is produced. Alright, so to ensure that the reaction goes to completion, there are two things that we'll do. Number one, we'll apply heat. We'll heat the mixture gently, and secondly, we'll stir. Alright, so how do we know that we have added an excess of zinc carbonate? Alright, there are two indications. Number one, that after stirring for a long time, and after there is no more effervescence, there is still some solid remaining. That means that the zinc carbonate can no longer undergo any reaction, meaning all your acid has been reacted. Alright, so once there's no more effervescence, there is some zinc carbonate remaining, we know that all the acid has been reacted. Now we need to perform a filtration. Why do we need to perform a filtration? Is to remove the excess zinc carbonate that we have added. Alright, in this case, when we do a filtration, we'll end up with your excess zinc carbonate in the residue, and we have your zinc sulfate solution in the filtrate. Alright, at this point in time, we need to determine whether we want the filtrate or do we want the residue. Since we are preparing zinc sulfate, we actually want the filtrate. Alright, however, now zinc sulfate is dissolved in water, so we have a soluble solid that's dissolved in water. We actually have a mixture. So how do we separate the solid from the liquid? If you recall in the topic of methods of separation, in this case we need to either do an evaporation to dryness, or we use crystallization. In the context of O-levels, evaporation to dryness would be reserved for sodium chloride. For all other salts, we'll recommend the use of crystallization. For the crystallization method, the first step is to heat the solution, or to heat the filtrate until it is saturated. Right? What does it mean by saturated? It means that the solution contains the maximum amount of solute that it can dissolve. Alright, so any more solid that comes out, any more any excess solid would come out in the form of crystals. Alright, so after heating until it's saturated, we need to let it cool down, and on cooling your crystals will start to appear. Now we need to separate the zinc sulfate crystals from the solution, so we perform a second filtration. Right, in this case your residue will be your zinc sulfate crystals, and your filtrate will be your solution. Alright, so in this case we want the residue. Alright, so again, like precipitation, the method is not complete because now the crystals may be contaminated with some of the solution, so we need to further wash with some cold distilled water, and then we need to try it by tapping it between pieces of filtered paper. Again, all the steps that I've just illustrated have been summarized over here, and there are certain steps that carry some meaning, and you're expected to know why certain steps are being carried out. For example, you need to heat the mixture gently. What is the purpose of heating? Is to speed up the reaction. Alright, and another reason for heating is to ensure that reaction goes to completion. Next, you need to stir until no more solid can dissolve. Right, why is the step necessary? Because we need to ensure that all the sulfuric acid or all the acid is used up. Alright, next we need to heat the filtrate. What is the purpose of heating the filtrate? Is to evaporate the excess water. So that the solution becomes saturated. Alright, next we need to allow the solution to cool. What is the purpose of allowing the solution to cool? Is for crystallization to take place. Alright, because as the solution cools, the solubility decreases, so the extra solid that cannot be dissolved would appear in the form of crystals. Alright, so cooling is to allow crystals to form. Alright, so the rest of the steps are similar to the precipitation method, and I shall not elaborate any further. There's another question that is more complex, which is why do we need to make sure that all the acid is used up? Alright, why do we need to add an excess of the insoluble solid? Now the reason is this. Let's consider the scenario where we have added less than excess of the solid, meaning for example, we have sulfuric acid and we've added just a little bit of zinc carbonate. Alright, so after all my zinc carbonate has reacted, what is left in my solution? I will have a mixture of sulfuric acid that's unreacted plus my zinc sulfate, which is the salt that we want to prepare. Now we have two solids that are soluble in water. Can you think of a method to separate them? The answer is no. Alright, there's no way to separate two solids that are soluble in the same solvent. Alright, so therefore the reason for adding excess of the insoluble solid is so that we can easily remove the excess reagent in the form of a solid by a simple filtration. Alright, so if we don't add excess of the solid, we will end up with a mixture of two solids that are soluble in the same solvent, and they cannot be separated. Now the last method that we'll look at would be the titration method. Alright, so in this case we have sodium nitrate, which is a spar salt, and we need to use the titration method. In the titration method, we have learned that we need to mix an acid and an alkali. So to prepare sodium nitrate, the acid that we will use would be nitric acid, and the alkali that we will use would be sodium hydroxide. Now the key to the titration method is that we need to add exactly the exact amount of nitric acid to react with the sodium hydroxide. There cannot be a case where there's any excess of one reagent or the other. They need to be added in exact amounts so that the products that we get would be just sodium nitrate plus water. Alright, once again, why do they need to be added in exact amounts? Is that the excess of any of the reagent would mean that we have two solids that are dissolved in the same solution, therefore we cannot separate them. Alright, so because of the requirement that we need to add exact amount of nitric acid with sodium hydroxide, the titration method consists of two stages, right, or two steps. Now in stage 1, we need to determine how much nitric acid to be added to sodium hydroxide. Alright, you may be wondering, can I do the other way around? Can I add sodium hydroxide to nitric acid? The answer is yes, you can reverse the reagents. Alright, so how do we determine how much the exact amount of nitric acid to be added to sodium hydroxide? Is to carry out a titration. Now at this point, you would have tried a titration before. Alright, so in a titration, we have a burette, we have a conical flask. The burette in this case would contain your nitric acid, and your conical flask would contain your sodium hydroxide. Alright, so we will start to add nitric acid into the sodium hydroxide in the conical flask. And how do we know that we have added just enough acid to neutralize all the sodium hydroxide? Is at the point where the indicator changes color. Alright, so in the first stage we need to add an indicator. Alright, the common indicator that we use in the lab would be your methyl orange. Right, when adding methyl orange to sodium hydroxide, the solution will give a yellow color. Alright, so at the point where you have added just enough nitric acid to neutralize all the sodium hydroxide, the solution will turn orange. So at this point you would know that you have added just enough nitric acid to neutralize all the sodium hydroxide. Now, so based on this stage 1, we would know the volume of nitric acid that's required to neutralize all the sodium hydroxide. So that leads us to stage 2, where we perform the exact titration, but this time in the absence of your indicator. Alright, purpose of stage 2 is to now prepare the salt and then to crystallize it. So in this case, it doesn't make sense to add your indicator, because your indicator will therefore contaminate the salt to be prepared. Alright, so the detailed procedure is as follows. First, you fill up your conical flask with 25 centimeter cube of your alkali solution, for example sodium hydroxide. Alright, and then we add 1 to 2 drops of methyl orange into the solution, which will make the solution turn yellow. And then we titrate the sodium hydroxide solution with acid from the burette until the indicator changes color from yellow to orange. And the next thing that we need to do is to record the volume of acid required to exactly neutralize the sodium hydroxide. And that will bring us to stage 2 or part 2, where we repeat the titration in the absence of the indicator to prepare the salt. Alright, so in this case, if we were to add the indicator, it will contaminate. The salt prepared. Alright, now when we repeat the titration, we have already noted the volume of acid required to exactly neutralize the sodium hydroxide, so we add this volume of acid into the alkali, and then for the solution that we have obtained, we will then perform a crystallization to obtain our sodium nitrate, to separate our sodium nitrate from the solution. Right, the rest of the steps are exactly the same as for the excess method, and that is for the titration method. Now at this point I notice an error in the heading, so this is for titration method and this is also for titration method. Alright, so at this juncture we have learned 3 things. One, when asked to prepare a certain salt, you should be able to determine what method to use. Secondly, you should be able to determine what reagents to be added to get the salt. And lastly, you should be able to list down the steps required to prepare the salts. And that's all for the chapter on salt.